We were working on solving exponential equations last week where we couldn't get a common base, so we had to add logs into our problem. Today, we are looking at problems that have logs in them, and we have to solve. So these start out with the log. Now, if I am looking at this first one, our whole goal is to get the x by itself, which means ultimately I have to get rid of the log, right? Last week we were using the idea that if you add a log to each side, that's a legal move. We could do that in reverse. If we have a log on each side, we could take them both away. But that only works if it's just the log of something. So I can't have 2 times the log. What could I do with my 2? Okay, we know properties of logs. If you have a coefficient, that can turn into an exponent. So that's log base 5 of x squared. Now I am down to 1 log on each side. So then we can use properties of logs and say, okay, I can drop those logs. So that means x squared equals 9. Square root plus and minus. So x is plus and minus 3. Anybody see an issue with that solution? Why can't it be negative 3? Remember with logs, the base and the argument both have to be positive. So this cannot equal negative 3. Always check on these. So x equals 3 is our final answer.
Which one's going to be negative?
The base and the argument. So a log can equal a negative number, but the others have to be positive. Questions there? Let's look at this. So what should I do first? Okay. Log base 2 of x cubed. And then what am I going to do on the other side? (27 to the negative 1). So you cannot have any coefficients there. All right, so now we can drop our log. So x cubed equals 27 to the negative 1. What is 27 to the negative 1? To get rid of a cube, you need a cubed root. Do you have to put a plus or minus with that? No, because it's odd. Cube root of 1/27 is 1/3. Do a quick check. If I put this in for x, my argument is positive, so it's okay. If I had gotten a negative 1/3, then your answer would be no solution, because you can't have a negative argument there. So always check on this. So far, so good? I'm going to do this one. be able to use the same strategy here? No. The previous problems were different because everything had a log in it. But here, I have a term that does not have a log. So even if I moved one of those logs over, I can't just drop it because I have a term without it. So instead, let's start over here. Both of these have logs. Is there any way to combine those? Think about your properties. If the logs are added, how can you combine them into one? Multiply. So you're welcome to go ahead and FOIL that out. Okay. So now, I only have a log on one side, so I can't just drop it. What else could I do? Go back to your definition. Can't we change that to exponential form? So this means 5 to the first power equals x squared plus 8x plus 12. Quadratics, we always need to set equal to 0. So if I subtract over my 5, what can I do with this? Approximately. Multiply 7 and add 8, that would be a 7 and a 1. Set each one to 0, so we get x to be -7 and -1. Okay, what do we need to do? Check. You have to put them into the original. If I put in a -7 plus 6 is not positive, so -7 will not work. If I put in -1, -1 plus 6 is positive, -1 plus 2 is positive, so that one is okay. So x equals -1 is my only answer there. Yes, ma'am.
Is there ever going to be 2 answers?
Yes, there could be 2, and there could be none. It just really depends. Other questions? Let's do this one next. Alright. Thoughts? Take your 3 to the exponent. I have 2 logs being divided. Subtracted now, so I can combine them with division. Kind of gave that one away. Okay. So we know if we have a log on both sides, we just drop them. But if I have a log on only one side, what do we have to do? Change it to exponential form. Alright, so you always start with the base. So the base of my log is 2. So it'll be 2 to to the 5th power equals my x minus 1 cubed over 4. So 2 to the 5th is 32. Multiply our 4. Then what do? Cube root. Can you do the cube root of 128? It's not going to come out pretty. Okay, we'll get to that in just a second. Then what would you do? Add your 1. So what I want you to do, just like with the others, we're going to give a decimal, correct, to 4 decimal places. Type that all in, and x is 6.0397. Any questions? Am I done? Gotta check it. Always check it. If I plug this in, 6.03 minus 1, that's positive, so I don't have to worry. That one works. Let's try. I think the first step will be here. Yeah, you've got to bring the log over so your log's on one side and the number's on the other. Why don't you guys try to finish this one then? So subtract over that log and then see if you can do it from there. You need logs on the same side since they're subtracted, you divide. Okay. Since both sides don't have the log, we have to use the definition to change it to exponential. If I don't have the base, what is it? 10. Okay. So it's 10 to the first equals 2x plus 1 over x minus 2. You can multiply your denominator. 10 to the first is just 10. So if you distribute, you get 10x minus 20. Subtract over your 2x, add your 20, and you get 21 over 8, or you could give your decimal 2.625. Okay. Check it. If I take that times 2 plus 1, I'm good. That minus 2, I'm good. So it works. Okay. How are we doing so far? Good. Let's look at, I have a ton of examples of these, so I'm going to do a few, and then if you want more, I'll go back and do more. I'm just kind of jumping around right now. Let's do, I'm going to do this one. What do you notice? They all have a log. Can I just drop it off everything? No, that works if you have one log on each side. So I have to start by combining these, so I only have one log. If they're added, how do you combine them? Multiplication. So if we distribute, we get x squared minus 4x. Now, I have one log on each side, so we can drop it. So subtract over the x and the 6, because we always set our quadratics equal to 0. Box method. What multiplies to -6 and adds to -5? 6. Positive 1. So each of those is 0 and x is 6 and -1. Are we done? Check. Do both of those work? No. 6 is fine, but if I put in -1, I've got errors in a couple spots. So the -1 is out. 6 is our only answer. Would you guys like more of anything in particular so far? Feel like you're doing okay with those? Let's try at least one last problem. And then if you feel like we've got it after this, then we'll move on. I'll give you a second to write this down. So I have a mess here. 4 different terms. But what do you notice about all 4 of those terms? They have a log. So if we have a mixture, if some terms have a log and some don't, our goal is to get the log on one side and change it to exponential. If everything has a log, our goal is to get down to a single log on each side and drop them. So if I'm looking at the left, how would I put those together? So it's log base A x minus 1 over x plus 6. On the right becomes log base A of and down to 1 log on each side. So now you drop the log. How would you go about solving this? So if I multiply these, you will have to FOIL. You get x squared plus 3x and minus x would be plus 2x minus 3. If I FOIL these, I get x squared minus a 2x and plus a 6x. Positive 4x minus 12. Quadratics, we always set them equal to 0. But when I go to subtract my x squared, what happens? Cancels out. So this is just linear. Get x by itself. So if I subtracted my 4x, gives me a negative 2x, add my 3. divided by -2. We get 4.5. Check it. Go back to the original. 4.5 minus 1 is positive. 4.5 plus 6 is fine. 4.5 minus 2 plus 3, all of those are okay. So it works. Any questions? You need more of any of these? Then the last thing I would like to do is just write down a little summary of all the different types of problems and what our strategy is. Because it's not so bad when I'm teaching you and we only do one type at a time, but when I start mixing them all together, you're going to have to be able to look at the problem and know what to do. So, if you have like an exponential, where you can't get a common base, the bases are different. That's what we did last week, so we added a log to each side. If you only have a log on one side, you change it to exponential. If you have a log on each side, you drop it. If you ever have more than one logarithm or exponential on a side, you need to combine them first and then do one of those 3 steps. And always check your answers. Tomorrow we're just going to do some review over mixing the different types of problems together, and then we're planning on a quiz on Wednesday. That's kind of where we're going.